Welcome back. So now we're going to identify key information from our graphs. This page is not in your notes. A very similar one is the one on the next page is in your notes. All right, so just kind of follow along here. All right, so for any particular polynomial, how can we determine how many relative maximum or minimum there are? Consider the following polynomial functions in factored form and their graphs. So when we're looking for relative maximum and minimum, we're looking for turning points. Right? Let's fill in each of these. We're going to fill in degree last. Right? We'll start with x-intercepts. I think that's the easiest thing. And then we'll look at number of relative max and mins, and we'll identify these are turning points. So I'm going to put this on mine. And then we'll figure out how many are relative maximums, how many are relative minimums, and where's our graph increasing or decreasing. Okay? All right, so, and actually, let's actually start with, we're going to go x-intercepts, and then we're going to go degree. Because this is in factored form, our degree is really easy to find. All right, so number of x-intercepts. All right, let's look at the first one. F of x equals x plus 1 times x minus 3. How many factors do you see? Right? And so notice that all those factors, they are x. They're not x squared. Right? So each one of them is going to count for an x-intercept. Number of x-intercepts we have are 2. Right? There are 2 x-intercepts because there are 2 factors. Right? All of our factors here are linear factors, which means there's no x squared. Right? So each one of them is going to count for 1 x-intercept. Let's actually write down what our x-intercepts are. We can see it from our graph, but even easier, at least with these graphs, I think even easier we can see it from our equation. Right? So there's our 2 x-intercepts. If we simply set x plus 1 equal to 0 and x minus 3 equal to 0, we have those values as well. And it's probably easier than looking at that particular graph. So we have an x-intercept at negative, whoa, that doesn't look like a negative 1. I never know where those little glitches are going to be. They're hiding, waiting to get me. All right, there we go. I outsmarted the glitch there. Negative 1, 0, and 3, 0. And let's write it over here and drag it over. Right, so notice all I did was add the opposite to isolate x. If I add 3 to both sides, x is 3. Subtract 1 from both sides, x is negative 1. That gives me my 2 x-intercepts. That matches what we see. I'm going to have to use a different color. So these are our x-intercepts. I'm going to write them on our graph. So this one was negative 1, 0. This was 3, 0. Number of turning points. There is 1 turning point, and that is, well, it's trying to be in the right spot. It's really thinking about it, but it's right there. Right? 1 turning point, right? 1 place where we change directions. Right? So there is 1 turning point. There is no relative maximums, right? Because notice that that is not the high point in the region. Our graph is decreasing and then increasing. That is a relative minimum. We have 1 relative minimum. And actually over here, let's write our turning point. Our turning point is right there at 1, looks like it's 1, 2, 3, 4. I could check, and this is actually a good opportunity to review how to find a vertex when it's in factored form or intercept form. Right? So if I add my x-intercepts, that gives me the x-coordinate of the vertex. So negative 1 plus 3 divided by 2. Right? So that's going to be 2 divided by 2, which is 1. If we plug 1 back in, right? Squeeze it over here. If we plug 1 back in, we would have 1 plus 1 and 1 minus 3. So let's see if I got it right, trying to estimate it on that graph. I don't know. All right, so we would have 1 plus 1 is 2. 1 minus 3 is negative 2. Phew, I got it right. Right? So our k value there, it moves over just a little bit. And so this is k is -4. So that's our vertex 1. Oops, I almost got it right. Silly me, forgot to write that negative in. 1, -4. So focusing on trying to figure out what that point was. 1, -4. So that is our turning point. And we'll write it over here, drag it in, obviously. Since that does not look like 1, -4. And that is a relative minimum. Before we go to increasing and decreasing, let's backtrack and go back to degree. So how many x-intercepts do we have? Remember, the number of solutions equals our degree. We have 2 solutions. There obviously are no complex solutions. This is already factored. And so this is degree 2. It's just a parabola. It's degree 2. And I'm going to put a little x squared here. And you can see that if we were to multiply that out, if we were to distribute or FOIL, right, we'd have x times x, that's x squared. Now let's talk about increasing and decreasing. I'm going to use green for increasing, go, 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 red for decreasing. Right, so notice our graph as we begin is going downhill, right? So it would have been going downhill, because remember we read graphs left to right. It would have been going downhill for -infinity, if we could actually reach there, all the way till we got to that turning point. We also call that turning point on a parabola a vertex. Right? It's called a parabola. I mean, it's called a vertex on a parabola. It's not going to be called a vertex on the other ones. Right? And so that's where we turn around. And never, it's the x-coordinate that gives us the where. So we're decreasing from -infinity to 1. I checked back. I just paused there. I checked back just to make sure I didn't forget a negative on the 1. Phew, I'm on the positive side. It's okay. All right, so -infinity to 1. And then we turn around and go, and we start increasing. And there we go. All right, so we're going to be increasing from 1 to infinity. Notice actually for all of these, increasing and decreasing together, because our domain is all real numbers, is going to be this. Actually, let me not write in green. I'll write in purple. I'm trying to color code here if you haven't noticed. All right, so increasing and decreasing together is going to go from -infinity to infinity. It's going to cover our entire domain. Notice we've got our entire domain covered there. -infinity to 1 and then 1 to infinity. That's everything. And that's all we're going to say about that particular parabola. All right, let's look at the next one. And we're going to go straight down this time. I'm not going to backtrack. All right, how many factors do I see? Notice there's no x squared, so every one of them counts for 1. I see 3 of them, right? So that means we're degree 3. This is an x cubed. And if you were to multiply it out, right, you'd have x times x, that would be x squared, and then you'd multiply by that last x, you'd have x cubed. Right, so this is degree 3. Our x-intercepts, we have 3 of them. 1 right there, 1 right there, 1 right there. Everywhere we cross the x-axis. Right, and for me, it's easier just to look up there at my factors. So 3 x-intercepts. If we set x plus 3 equal to 0, -3, 0 is 1 x-intercept. X minus 1 equals 0, 1, 0 is a second one. And then x minus 4 equal to 0, 4, 0 is the third x-intercept. But even if we didn't have the factors there, then hopefully we'd have a nice clear graph that doesn't seem so pixelated, and then we'd be able to figure out the x-intercepts from our graph, or estimate it the best we can. Fortunately, on the next page, the graphs are just a little clearer, but I liked the activity anyway, even though my graphs are a teensy-weensy bit pixelated. Let's find our turning points. Where do we turn around? Right, now they're not going to be called a vertex. Right, we turn around there. Right, so we go in one direction, we turn around, we go back, we go the other direction, then we turn around. So we have 2 turning points. And those 2 turning points are located at So now I'm going to have to estimate just a little bit. I'm going to call that 1.5. We don't have a way to figure out, like vertex, we can use a formula to find our vertex from our intercepts. Yeah, that doesn't happen for our parabola here. So I'm going to have to estimate. I'll tell you what you'll do when you're graphing. But since this is when we get to it, since this is already up here, we're going to estimate that. That appears to me to be 1.5. And if I'm looking at these lines here, 1, 2, 3, 4, I'm going to call that 1.54. Right? So we have 1 at 1.5, negative 1.5. The more effort I put into counting, the more I forget my little negative. There he is. Negative. Let's move him over there. Negative 1.54. Right, and then we have another turning point. I'm going to call that 2.5. And 1, 2, I think that's negative 2.5. I think it's at 2.5 on the x and then negative on the y. Right, so 2.5, negative 2.5. Relative maximums, all right, so that we look for, do we have a high point? We do have a high point. That high point, that little peak there, is at negative 1.54. And then we have a relative minimum, a low point, 2.5, negative 2.5. Notice that the relative max has a positive y value, and the relative min has a negative y value. Now, that's not going to necessarily always be true. What if both those turning points were below the x-axis? Well, then they could both be negative, but one would be less negative, right? Or what if they were both above, right? They'd both be positive, but one would be more positive, right? But not in this case. Increasing, right? So just think if we're going on a roller coaster, right? Where is the more exciting part? Where are we going? Actually, I should have reversed the colors, I just realized. I should have decreasing as green. That's where you go, go, go. And I think I did that before. So you haven't put this in your graph. I'm going to reverse my colors. Oops, not move my graph. In my head right now, when I was doing this podcast, I was thinking increasing, so up, and decreasing down. But I'm going to think of it as a roller coaster, because roller coasters are the best. And let's call the increasing part red, because that's where the roller coaster is exciting when you're going up, at least in my opinion. All right, so let's call that. We're increasing from 1 to infinity, and decreasing, that's the fast part, wee down the hill, right? So it was decreasing from negative infinity to 1. I'm just going to switch my colors. Trying to be consistent with my quadratic podcast. All right, so let's look at where we're increasing and decreasing here. All right, so we're going up the hill, and then we turn around, and we go down the hill, wee. And you should do that when you're finding increasing and decreasing. When you get to the decreasing, go wee, and then we go up the hill. All right, so we are increasing. Now, it's always going to start at negative infinity, right? Whether it's increasing or decreasing, it kind of just depends on your graph, right? So for the first graph, it was decreasing from negative infinity. And then on this graph, it's increasing from negative infinity. But negative infinity is going to be your starting point somewhere, right? So here, negative infinity is my shadow was blocking the increasing. And then it stops increasing at our turning point, negative 1.5. And then it increases once more, right, from 2.5 to infinity, where we have it in red. It's decreasing, so the good part of the roller coaster is just between negative 1.5 and 2.5. That's the exciting part where you're going down the hill. Let's look at our last graph, and then we'll look at the ones on your notes. And I think I have my computer as far away from my smartboard as conceivably possible. I'm running out of room to move. Okay, now I moved my computer 3 inches. All right, so I'm going to grab a purple pen just to be consistent. All right, so how many x-intercepts do we have? Let's look at our equation there. They're all linear factors. I mean, there's no squares. So we have 1, 2, 3, 4. You see 4 x's? All right, that means this is degree 4. This is x to the 4th. Right? If one of them had been an x squared, that would count twice. But since they're all just x's, they all count once. All right, so number of x-intercepts. We have an x-intercept here, 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 and here. All right, so there are 4 x-intercepts, and that's why we're at degree 4. Right, and so our x-intercepts are, well, x equals 0. Then we have x plus 4 equal to 0. So by the way, x equals 0 here is going to be 0, 0. We have x plus 4 equals 0, so that's going to be negative 4, 0. And then we have x minus 2 equal to 0, so that would be 2, 0. And x minus 5 equals 0, so I'm going to have to write underneath it here. And that would be 5, 0. And that matches our graph. There's our 4 x-intercepts. Turning points. So we turn around here, we turn around here, we turn around here. We have 3 turning points. One that appears to be, I'm going to call that 3, negative 3. And I don't even know how to count these things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll just say every dash is 1. So we have 3 turning points. One of them is at negative 3, 12. And then, oops, let me write that in there. We have another one right here. I think that looks like 1, 2. I'll just put it like this. And then one more right here. And 1, 2, my dot's so big there, 3, 4. So actually we know this has to be 5, that last blue dot. So this must be 4. 4, and let's see, this was 12, 11, 10, 9, 8, 7, 6, 12, 4, 6, I think. And you can tell me if you think otherwise. All right, so let's see how many of them are relative max and how many are relative mins. Well, only one is a relative max. We have one relative max, and that's that point there, 1, 2. That one is a relative max. I guess I don't really need to put a number in there. You can see there's only one point given there. We have 2 relative mins, 2 low points there. We have negative 3, 12, and 4, 6. So by the way, this is not an interval, so I'm not using union. It's just 2 separate points. I could have put a comma. I really didn't have to put an and in here. All right, so increasing, decreasing. All right at the beginning, our roller coaster goes wee downhill. And then we turn around and go uphill. And we turn around and go downhill. And turn around once more and go uphill. All right? So make sure when you're reading graphs, you go left to right. If you want, draw yourself a little roller coaster car. Imagine it's a little roller coaster going down the hill or up the hill. Which way is it going? Is it going down the hill or up the hill as you go across the graph from left to right? I think that's the easiest way to think of it, because students have a tendency to want to look at the center, and then they go to the right, and then they go to the left. No, you're going to go left to right, just like you read. All right, so it's increasing, where you see the red, from negative 3 to 1. Right? Remember, we list the x's, negative 3 to 1, and then again, so this is an interval, so I am going to use the U symbol, union for and again from 4 to infinity. Right, and where am I decreasing? Well, right off the bat, we're decreasing. This is the exciting roller coaster. You start decreasing right away. So negative infinity, and then we stop decreasing at negative 3. And we start decreasing again at 1. And we stop at 4. Notice if we look at all those little pieces, negative infinity to negative 3, negative 3 to 1, 1 to 4, 4 to infinity. We got the whole domain, negative infinity to infinity covered. Right, between the 4 pieces. If you don't have negative infinity to infinity covered with your 4 pieces, you have made an error somewhere. For polynomials, the domain is all real numbers, so negative infinity to infinity. Let's do one more, right? And it's the one on your notes. And this one also has 3. And nicer pictures. Right? Although the y coordinates, no clue. Right? So the graphs are clear. It's easier to see the x's, x values, y values. There's nothing listed. Right? So when we list relative maxes and relative mins, right, we're going to count the number and we'll mark it on the graph. Right? But we're not going to actually have y values for these. Right, so below are the complete graphs of some polynomial functions. Right, so they are the complete graphs because you see there's arrows at the end. That's showing it's going to keep on going forever and ever and ever in both directions. The negative side on x and the positive side on x. Right, so we're going to figure out is the function to an odd degree or an even degree. And then we're actually going to figure out not just odd or even, but what is that degree? All right, let's look at the first one. All right, so it is, we see the ends are going different directions. That's an odd degree. And actually, let's mark them. Let's go right across and do degree first for all of them. All right, so is there any other graphs where the ends go different directions? Hopefully you said number 10, Miss Mashagny, it's going different directions. Because that's the one. All right, so we know our 2 odds. The other one, ends are going the same direction. That is even. All right, now I got to figure out degree. All right, so I only see 2 x-intercepts. It must be degree 2. But is 2 an odd number? Hopefully you're scratching your head and going, no, not an odd number. If you remember in the previous lesson, right, where we were writing the equations, we talked about something called multiplicity. Right? So if you notice, my graph, it touches the x-axis, right? So it touches right here, and then it turns around the other way. Right? So it's going, it touches, and it goes back the other way. Right? So that does not count for 1 x-intercept. It counts for 2. This is multiplicity 2. That counts 2 x-intercepts. So we have 2 x-intercepts at 1, 2, 3 at negative 4, 0. Right? And I'm going to put next to that times 2, right? Because that counts twice. And then we have 1 more there at 0, 0. So we know it's multiplicity 2 because, and you can put this in your notes, we touch and turn. If it doesn't cross and it touches, it's an it's an even multiplicity. So if you touch and turn, it's even multiplicity. If you cross, so here it's crossing, this is just 1 x-intercept. Right? So right here I have multiplicity 1 because the graph crosses. All right, so that counts for 1. So together, that's 1, 2, 3. Now, how else could I have known that that must be degree 3 and not degree 2? Well, first of all, degree 2, that's even. Ends are going to both be going in the same direction. And they're not, so it can't be degree 2. Another way we can tell is by the number of turning points. So if you notice, we have, let's write in our turning points here. And I'm going to use purple for turning point this time. All right, so turning point is right here. I'll write out, I have enough room, I'll write turning point. And this one over here, it's an x-intercept, but it's also a turning point. All right, so we have 2 places where we have turning points. So if we have 2 turning points, number degree is 1 more than your number of turning points is going to be at most 1 less than the degree. Right? So if I have 2 turning points, there's no way I could be degree 2 because degree 2 has only 1 turning point. Right? So this is not only odd, this is an x cubed. Right? So let's go to our other odd graph. Right? So this one has 1, 2, 3, 4, 5 x-intercepts. Right? And we can write down the x-intercepts. The x-intercepts are 1, 2, 3, 4, negative 5, negative 5, 0, and negative 1, 0. Actually, I'm going to write them on the graph too. Negative 5, 0. I'll do that over here too. This one was negative, whoops, get the negative in there. Negative 4, 0, and 0, 0. Those are x-intercepts. Negative 5, 0, negative 1, 0. It's hard to fit this in. 1, 0. 3, 0, and 5, 0. And so we'll write them down here too. So negative, and we are not putting any ands in here. There are 5 I have to write in. Seriously. Negative 5, 0, negative 1, 0, 1, 0, 3, 0, 5, 0. Can we squeeze that in? 5, 0. There we go. All right, those are 5 x-intercepts. So that's leading us to believe it's degree 5. If we count our turning points, well, and you know what? I'm going to abbreviate TP over here now. I already wrote turning point once. You'll figure it out. So we have a turning point here, and a turning point here, and a turning point here. There's just no room for me to write turning point each time, and a turning point here. So I've got 1, 2, 3, 4 turning points. So number of turning points is 1 less than the degree. This is 5th. So this is an x to the 5th. Our middle one there, even, and we've got, in terms of x-intercepts, we have 1, 2, 3. That's not x cubed. They're not going opposite directions. However, this one is multiplicity 2, right? Because we touch and turn, and the other ones count for 1. So our x-intercepts are 1, 2, 3, 4, 5, negative 5, 0. I guess that looks like a negative. Negative 3, 0. And 1, 2, 3, 4, 5, 0. And that counts twice. So let's put that on our graph. That's really bothering me. I'm going to write that nicer. All right? Let's put that on our table. All right? So our x-intercepts are negative 5, 0, negative 3, 0. And 5, 0, and that one is times 2, multiplicity 2. All right, so we've got our degree. Oops, this is x to the 4th. We've got our x-intercepts. We're going to change our x-intercepts to factors. That would be excellent practice for us, and remembering how to go from an x-intercept to a factor, because that'll help you write equations. Of course, I'm doing this after the equations, but that's okay. I did it there too. All right, so our x-intercept is negative 4. The factor is going to be x plus 4. But are we done? How many do we have? We have 2. It's x plus 4 squared. So, by the way, we're not going to write the equation here. We're just going to write it in the factors. We're not going to solve for the a. We'd have a heck of a time solving for the a. You know why we'd have a heck of a time solving for an a? Do we know a y value other than the x-intercepts? No, not at all. So we'd have a really hard time solving for the a. Now I moved that over, if you were happy to notice, that x plus 4 squared over a little bit, because I think I'll put my other one in front. There's no real reason, we have 1 at 0, 0. There's no real reason I should write x minus 0. Right? That's kind of silly. If you're subtracting nothing, it's just going to be an x. So let's just put x. So there's our sort of our equation in factored form. It's just the factors. It's not doesn't use the value of a because we don't have any y values. Right? So let's go to the other graph. We'll just go kind of across this time, and we'll talk about each thing for every graph. Right? Here are factors. We're going to take our x-intercepts, and then you have to change the sign, right? Because when you set x plus, for instance, in the first one, if we set x plus 4 equal to 0, we get negative 4. If you set x plus 5 equal to 0, you'd get negative 5. And the same thing with x plus 3 equal to 0, that would give us negative 3. And if you have set x minus 5 equal to 0, you'd get 5. But there's 2 of them, so that's a squared. And now the last one here. And we got a lot of factors, and there's no repeated. All right, so if 1's a intercept, x minus 1's the factor. If 3 is an intercept, x minus 3 is the factor. If, oh, I forgot all the ones on top, that's right. If 5's an intercept, x minus 5. And then let's do the ones right above it that I totally forgot. I'm just going to just move that down, I guess. I want to kind of put them in order so it kind of makes sense. As we're looking at each of the intercepts, how they go with each of the factors. So this would be, so negative 5 would be x plus 5, and negative 1 would be x plus 1. And there we go. There's our 5x intercepts. Relative maxes and mins. All right? We can say how many they are. I'm at 30 minutes. Ooh. I can say how many there are, but I can't really say the point. All right, so we have one relative max. And let's just call that, well, that one is the only one I can actually name. Well, that's one of 2 I can name. We have a relative max at negative 4, 0. The x-intercept is also a relative max, right? Because we changed directions there. We have a relative min here, and I don't know what the y value is, but the x is at, looks like negative 1.5. So right here. So let's just call that negative 1.5 y1. Right, so we have 1 there at negative 1.5 y1. And let's do increasing and decreasing together with turning points, because that's what tells us increasing or decreasing. All right, so we start off, I used the wrong color again. We start off and we're increasing. Not that it really matters, but this is the slower part of the graph. At least it is on a roller coaster. So we're increasing, and then we're decreasing. We go down the hill, whee! And then we turn around and go back up the hill. And forever and ever we're going up a hill. So maybe not the most interesting roller coaster if you're going to keep going up a hill. So we're increasing from negative infinity. Remember, we read left to right, negative infinity, and we stop increasing at negative 4. And then we start increasing again at 1.5, negative 1.5. I'm going to write underneath negative 1.5. And then we're going to keep increasing forever and ever and ever. We're decreasing just between negative 4 and negative 1.5. Let's go to the next graph. Right, so we're going to write in our relative max and mins. Right, so we have 2 relative maxes. Right, one is right here. And I should really move this, because that goes with that. It is not a relative max, so at negative 4, whatever y is, so we'll call it y2, is our one of our maxes, and we have another relative max right here at 5, 0. All right, so relative max, negative 4, y2, and 5, 0. Relative min right here, looks like it's 1. And we'll call that y3. Right, and let's do our increasing, decreasing. So we go up the hill, and we turn around, and we go down the hill. Whee! And then we go up the hill. And then we turn around, and we go down the hill. So if you have different colored pens, it would be good if you marched it that way. Or you could, I'll do it on this one, you could write decreasing, increasing. I won't do this for every single graph. I'm actually going to do it in that one, actually. All right, so wherever it's red, it's increasing. Wherever it's green, it's decreasing. All right, so we're increasing right off the start from negative infinity. And we stop increasing at negative 4. We're increasing again from 1, and we stop increasing at 5. Okay. And then we start decreasing at -4, and we stop decreasing at 1, and then one more time we start decreasing at 5, and then forever and ever we're decreasing. So that's a better roller coaster. We're decreasing forever. And the last one here with lots and lots of turning points. All right, so all of our different turning points. All right, so we have one that looks like -4, and that's y4. We have another one so close to my x-intercept, I can't get it in. Let's move this up here. All right, so we have one right here. I guess it's 1/2. 1/2 and y5. And then we have another one right here, and that one is at 1, 2, looks like 3, y6, and 1, 2, 3, one last one, and it's so close to my y-intercept, it's right there, I mean my x-intercept, I can't even get it in. It's at 4 and y7. All right, so we're going to be increasing, and then we're decreasing. Whee! And then we turn around and we're increasing. And then we turn back and we're decreasing. Oops. Whee! And then forever and ever and ever, we're going to be increasing. All right, so we're increasing from, oh, I didn't put the relative max and mins in. I'll do that real quickly and then do the relative, the increasing, decreasing. Relative max at -4 and y4. Another one at 3, y6. And that's it. Right, wait, 1, 2, that's it. All right, relative min at 1/2, y5. And one more at 4, that's a y7. I've already used y1, that's got to be 7. y7. All right, so we're increasing from -infinity to -4, and then again from, I think it's a 1/2 to 3. I'm looking for the coordinates. 1/2 to 3. And one more time from, oops, I'm putting in, commas are for points, U's are for intervals. Let's try that again. -infinity to -4, and 1/2 to 3, and what on earth is that point? 4 to infinity. Right, where the red is. And then we're decreasing just from -4 to 1/2. And what are you? You are 3. No, 4. Here it is. And then 3 to 4. Sorry, 3 to 4. I'm trying to follow my arrows. It got a little crowded over here. 3 to 4, right? Here is 3, right? Because and here's 4. And there we go. So a little longer than I planned. However, you now know all you need to about finding turning points, increasing, decreasing from a graph. Right? And turning x-intercepts to factors. And I do believe that is my last slide. And I am correct, because that's a whole nother lesson. Bye for now.